Have you ever stopped to wonder what time truly is? It seems like such a fundamental part of our existence, doesn't it? We measure our lives in it, the seconds ticking by on a watch, the years marking our birthdays. It feels as real as the ground beneath our feet or the air we breathe. We feel it push us forward, from a past we remember into a future we can only imagine. But what if this constant flowing river of time is not as real as it seems? What if it's more of a grand illusion, created by something much deeper and stranger happening at the very fabric of the universe? This is one of the most profound questions in modern physics. Scientists are beginning to suspect that time isn't a basic ingredient of the cosmos. Instead, it might be an emergent property. Think of it like wetness. A single molecule of water isn't wet. Wetness only appears when you have a vast collection of water molecules interacting together. In the same way, time might not exist at the most fundamental level of reality. It might be something that arises from the collective behavior of countless quantum particles, a feature of our macroscopic world that is absent from the microscopic realm. It's a staggering thought, suggesting that the very framework of our lives is a secondary effect, not a primary cause. This radical idea challenges everything we intuitively believe. Our entire language and way of thinking are built around the concepts of before, now, after. For all of human history, we have imagined time as a great, flowing river. It moves in one direction only, carrying us relentlessly from the cradle to the grave. The past is upstream, a landscape we have already traveled through, its features fixed in our memories. The future is downstream, a territory shrouded in mist, waiting to be discovered. The present is simply our position in the boat, that infinitesimally small moment where the known world gives way to the unknown. This metaphor is so powerful because it perfectly captures our subjective experience. This concept was formalized in physics by Isaac Newton. In his world, time was absolute, universal, and independent of everything else. It was like a cosmic metronome, ticking away at the same rate for everyone and everything, everywhere in the universe. An hour on Earth was precisely the same as an hour on Mars or in a distant galaxy. This absolute time was the backdrop against which the drama of the cosmos played out. It was the ultimate, unchanging stage. This view makes perfect sense in our everyday lives. When we arrange to meet a friend at a specific time, we assume that our clocks are marching in lockstep, governed by this single, universal flow. Even Einstein, who revolutionized our understanding of time, didn't entirely do away with this idea of a timeline. His theory of relativity showed that time is not absolute, it's relative. Now, let's step into the strange and wonderful realm of the quantum. At this tiniest of scales, the familiar rules of our world break down completely. Here we encounter a phenomenon that is so counterintuitive, it famously prompted Albert Einstein to call it spooky action at a distance. This phenomenon is quantum entanglement. Imagine you have two particles, let's say two electrons, that are created together in a special way. They become entangled, which means their fates are linked no matter how far apart they travel. They're like a pair of cosmic twins who share a mysterious, instantaneous connection. Let's say these particles have a property, like spin, which you can think of as being either up, down. The rules of entanglement dictate that if one particle is measured to have a spin that is up, its entangled partner, at that very instant, will be found to have a spin that is down, and vice versa. The strange part is that before you measure them, neither particle has a definite state. They exist in a fuzzy, probabilistic cloud of all possibilities at once. It's only the act of observing one that instantly forces the other into a definite state, even if it's on the other side of the galaxy. This connection seems to defy the cosmic speed limit, the speed of light. Information about the first particle's state appears to travel to the second particle instantaneously, which shouldn't be possible according to Einstein's theory of relativity. This isn't about sending a secret message faster than light. You can't control the outcome of the measurement to send information. Instead, it's a shared reality between the two particles. It's as if the space separating them doesn't exist. They behave not as two separate entities, but as a single unified system, regardless of the distance. This spooky connection is at the heart of the new thinking about time. This bizarre property has been confirmed in countless experiments. It's not a theoretical quirk, it's a real and fundamental feature of our universe. To grasp how entanglement could give rise to time, let's use an analogy. Imagine the entire universe is a giant, unassembled jigsaw puzzle. At the very beginning, all the pieces are just a jumbled pile on a table. There is no picture yet, no structure, no sense of a story or progression. This jumbled state is like the universe at its most fundamental level, a static, timeless collection of quantum bits of information. There is no before or after in this pile of pieces, everything just is. In this state, there are only correlations and connections between the pieces, but no sequence. Now think of quantum entanglement as the way the puzzle pieces fit together. Each piece has uniquely shaped edges that correspond to other pieces. One piece with a particular tab might be fated to connect with another piece that has a matching indentation. This is like our entangled particles. Their properties are linked. They are not defined on their own, but only in relation to one another. You can't understand one piece without seeing how it connects to its partners. This web of connections, this set of rules for how the pieces fit, is the fundamental reality. It's a static network of relationships. As we start to connect the pieces, a picture begins to emerge. You connect two pieces, then a third, then a fourth. With each connection, a small part of the image appears. A patch of blue sky, the corner of a building, a piece of a face. What you are doing is creating a sequence. You are experiencing the process of building the puzzle. This process, this sequence of fitting pieces together, is what feels like the passage of time. Well, the theory, proposed by physicist Don Page William Wooters, is known as the Page-Wooters mechanism. It suggests that time can actually emerge from a completely static, timeless quantum system. Imagine the entire universe as one single gigantic quantum state. This so-called universal wave function doesn't change or evolve in time because there is no external time for it to evolve in. It just exists, a frozen, timeless mathematical object containing all possible configurations of the universe, all tangled up together. Now let's divide this static universe into two parts. One small part can be considered our clock, the rest of it is the universe that this clock measures. The key here is that the clock is entangled with the rest of the universe. Think of it kind of like a flip book. The entire flip book with all its pages exists at once. It's a static object. But if you are a tiny character drawn on one page and you can only perceive one page at a time, your experience is one of motion and change. Your clock is the turning of the pages. As the page turns page 1, page 2, your world changes. From your perspective, time is flowing. But from an outside perspective, looking at the whole book, there is no flow, just a sequence of static pages. Entanglement links the state of the clock, the page number to the state of the universe, the drawing on that page. This means that change, and therefore time, is a relative concept. It only makes sense when you compare one part of the universe to another. There is no absolute external master clock ticking away. There are only correlations between subsystems. One of the deepest mysteries about time is its directionality, the arrow of time. Why does time only seem to flow forward? Why do we remember the past but not the future? Why do eggs break but never unbreak? The traditional explanation is the second law of thermodynamics. It says total entropy, disorder, always increases. A neat, tidy room becomes messy over time. A messy room never spontaneously tidies itself. This increase in disorder gives time its arrow. The entanglement-based view offers a complementary perspective. Here, the direction of time aligns with increasing entanglement. You connect more and more pieces. The structure becomes more complex and interconnected. The past, few connections. The future, many connections. Assembling the puzzle, increasing entanglement, goes one way. You can't unconnect the pieces and return to a jumbled pile without undoing the work. If time emerges from entanglement, what does this mean for our picture of the universe? It means there is no single, universal now. The idea of a simultaneous moment across the cosmos becomes meaningless. My now is defined by the state of my local clock and by its entanglement with my immediate surroundings. Your now, in a distant galaxy, is defined by the state of your clock and your surrounding environment. There's no absolute framework to say my now is the same as your now. This idea exists in Einstein's relativity and becomes more profound in the quantum context. This leads to a block universe view with a quantum twist. The block universe is the idea that past, present, future all exist equally. The entire history of the universe is a static, four-dimensional block of space-time. Emergent time says fundamental reality is static, the timeless quantum state of the entire universe. Yet the experience of a present and flow of time is a valid, subjective reality for any observer inside that block. Our consciousness doesn't move through the block. Our consciousness is a process within the block. Where does this leave us as human beings who live and breathe in time? Does it mean our lives, our memories, our hopes for the future are less real? Not at all. It simply reframes them. Our experience of time's passage is perfectly real for us. The joy, the sorrow, the anticipation, these are all genuine parts of the human condition. The new physics doesn't invalidate our experience, it seeks to explain its origin. It's like discovering that the beautiful colors of a sunset are caused by the scattering of light in the atmosphere. The knowledge doesn't make the sunset any less beautiful, it adds a layer of deeper wonder to it. Thinking about time in this way invites us to see ourselves not as passive passengers on a river, but as active participants in the universe's becoming. Our consciousness, our choices, our interactions are part of the process that weaves the cosmic web of entanglement. We are not just observers of the universe, we are integral parts of its evolution.